solve for quadratic equations. Yesterday you guys were graphing them. Today we're going to actually solve them. So there are going to be no more graphing today. It's all going to be done factoring, and then we're going to solve for our two x values. So for instance, if you guys look at this picture up here, notice how my parabola crosses my x-axis in two places. Okay, this one right here is x equals 1. That's where it crosses at. This one over here, what, x equals -3? Those are the two things that we're going to be solving today. So when I say, what does it mean to solve a quadratic? What you are looking for are the two x-intercepts, the 2 points where your parabola would cross the x-axis, okay? Most of the time it will cross twice and you will get two different x values. Do you think they always have to be whole numbers? No. I mean, you've got all kinds of numbers along here, so if all we're doing is solving for where it crosses, it doesn't have to cross at a whole number. You may get two whole numbers, you may get one whole, one fraction, or decimal, or you might get two decimals, okay? Also, there will be times when this parabola only crosses once, so you may only get one answer, all right? So down here at the bottom, this is something pretty important that you need to pay attention to. What I want you to do above this box, I want you to write x squared minus 4x minus 21 equals 0. Okay, write that quadratic down for me. We're going to factor it. Okay, remember 2 days ago when we talked about factoring, if there are 3 terms, we make an asterisk. Okay, so let's get this set up. The top comes from 1, so A, times C. So what's 1 times -21? -21 goes up top. The B term, so the number in the middle, goes at the bottom. So -4 goes at the bottom. And what goes here and here? Ones, the ones, right? A. So 1 and 1, and I always split this in half. So if this is x squared, I'm going to give this an x, and I'm going to give this an x. So then what you guys would do is you would look at your factor sheet, and you always look at the top number on your factor sheet. So you're not looking at 4, you're looking at the row of 21. And when you look at the row of 21, you only have 2 options. You've got 1 and 21 or 3 and 7, right? What's the only pair that somehow makes 4? The 3 and 7. Okay, so we know our 2 factors are 3 and 7. The only thing is, we need to know, are they 2 positives, 2 negatives, or 1 of each? And if they're 1 of each, which one is which? Okay, well, the only way to get a negative product when you multiply is to have 1 of each. And if there's 1 of each, the bigger number, the 7, has to match the bottom. So your 7 has to be the negative, and your 3 is the positive. So here are the 2 sets of parentheses, right? X plus 3 and x minus 7. Same 2 sets of parentheses in that box. I did that on purpose. Okay, so what you guys would do is you would start off by factoring like we did Monday, but on Monday, there was no equal sign. On Monday, you guys would have just had x squared minus 4x minus 21. And you would have written your 2 sets of parentheses and you would have been done, okay? But now, because there's an equal sign, we can actually solve this. That's what this box is all about. Once you have your 2 sets of parentheses, if I just cover this up with my finger, just look up there. If this times this has to equal 0, doesn't something under one of my fingers have to equal 0? I mean, the only way to get 0 is if one of my numbers is 0, correct? Maybe both of them are. So all you guys have to do is whatever is under each of my fingers, set each set of parentheses equal to 0. So for instance, I'm going to take this one right here. I'm going to write x plus 3 equals 0. And then I'm going to take this set of parentheses, and I'm going to set that one equal to 0. Bless you. You're welcome. And then all you guys have to do is solve each of those. And that's simple. Those are just one-step equations. How do you solve this one? Yep. So I'm going to get x equals -3. And how am I going to solve the one over here? You're going to what? Add 7? That's what you said. X equals 7. There are my two answers. Now, this is taught in Algebra 1B. So those of you that had 1B last term, that should look familiar. And for those of you who have done this before, most people know that if these are the two sets of parentheses, they know when they set them equal to 0 that it's just going to give it the opposite answer, right? If this says x plus 3, I know my answer will be -3. If this says x minus 7, I know my answer will be +7. So I'm going to tell you right now, because some of you guys have done this plenty of times and you already know what you're doing. What I expect to see on your paper, I will always expect to see factored form, so the two sets of parentheses set equal to 0, and then I will always expect the two answers. If you are already comfortable with these, you don't have to actually break those apart and show your steps. Now, some of you benefit from showing your steps, so some of you may just want to show it anyway. But I'm okay, you know, once you guys get to Algebra 2, I am not nearly as particular about you have to show me every single step, because some of these problems would take forever if you did that. But again, some of you guys know yourselves. You know that some of you know you'll do better if you actually break it apart and show your steps. Either way, just make sure you guys understand where this answer came from and this answer. It's just the opposite. Now it's just the opposite because that's a 1x. If this had said 2x plus 3, you could not just go straight to your answer because it would be 2 steps. All right, is that okay? I'll tell you guys, if you're comfortable with factoring, especially asterisk problems, what we're about to do today, this should be pretty simple for you because it's just one extra step essentially. If you're still struggling with factoring, then obviously that could become an issue because the factoring has to be done first. All right, go ahead and turn the page. And what I'd like you guys to do is over in this blank space, just make a sketch. It does not have to be perfect. Just make an X and a Y axis. And then just draw a parabola. So the question over here says, what does it mean to solve a quadratic? So I already told you, when we are solving quadratics, what are we solving for? We're solving for x, which represents what? The what? Finding the x intercepts. You're looking, you're solving for where it crosses the x-axis. Those are called x-intercepts. Okay, so I just wrote, we are finding the x-intercepts, and that means we're finding where it would cross the x-axis. So in the picture that I drew, how many solutions would I have? How many times that one crossed the x? Okay, so this one here would have 2 solutions. Okay, so this one has 2 solutions because it crosses twice. Okay, but if I draw this parabola, okay, so that orange one that I just drew facing down, how many times does it cross the x-axis? Just once. So this one would just have 1 solution because it just crosses 1 time. Do you think I could draw a parabola somewhere where it will never cross the x-axis? Yeah, because I could like draw one somewhere up here, right? I mean, if I drew it there, is that ever going to come down here and cross the x? No. So this one would have no solutions. And I'm going to be particular here. Most of the time, you are going to get 2 solutions. Every once in a while, you'll get 1. And if it never crosses the x-axis, technically there are no real solutions. You will learn all about imaginary numbers tomorrow. And if there are no real solutions, guess what they are? They're imaginary solutions. Imaginary numbers exist in math. It's super fun. Anyway, those are your options there. But I think today on every single problem you guys do, you're always going to get 2 of them. Okay? For the most part, that's what happens. All right, so down here, let's go. In order to solve these, most important thing is that the quadratic has to be set equal to 0. If it is not set equal to 0, you are going to have to move stuff around to get everything over on one side of your equation. Okay? Good news is this one's already set equal to 0, so we're just ready to go. There are 3 terms, so we're immediately going to an asterisk problem. Well, also, they didn't have anything in common, so I didn't have to do a GCF. Okay? Always check that first. What is 2 times 15? 30 up top. And then the negative 11 goes at the bottom. And then here and here, they're not 1s this time. They're 2s. And then each one gets an X. So for 30, here are your options. I mean, you guys don't have to write these down on your paper. You're looking at it on your factor sheet. I'm just writing them up here because I don't have my factor sheet. So we've got 130, 215, 310, and 56. What's the only pair of numbers that will somehow make 11? Okay, so we know it's 5 and 6. Okay, but think about this. If they were both positive, this should be positive 11. If they were one of each, that would be a negative 30. So we know they have to match each other, but instead of being 2 positives, they have to be 2 negatives. So we've got a negative 5 and a negative 6. When you have any number up here that's not a 1, one side should reduce. Sometimes both will, but definitely one of them. Will the 2 and 5 reduce? No. So I'm going to go ahead and copy down 2x minus 5 over here. Okay, now 2x minus 6. So they're both divisible by 2, right? So we have a 1x minus 3. So that would be my second set of parentheses. So you have 2x minus 5 and x minus 3, and then make sure after that put equals 0. Okay, so depending on who you are and how much experience you have with these, this one right here, this one, I could go straight to my answer, no problem, because it's just a 1x. I know I would add 3 and I'd get a positive 3, right? Okay, so if you are somebody who already understands that, you don't have to show this step that I'm doing right here, because you know it's going to be a positive 3 anyway. This one. I mean, I could do it in my head. I'm sure some of you could do it in your head. But since it is 2 steps, I usually write those out. Like I would put 2x minus 5 equals 0. I would show this one and not show this one. That's how I would do it. But again, it's your call. I would go ahead and add 5. So I'd end up with 2x equals 5. But then we're dividing by 2. Now, I always leave my answer as a fraction, and that's because why should I type something into a calculator if I don't have to? The answer is staring right back at you, right there, 5/2. Now, I just assume most of you will probably type it in anyway. So, I mean, if you type it in, you're just going to get the decimal version. So you would have put 2.5 on your paper. I don't care which way you do it. I think a lot of people don't like to do fractions because if this had been 10 over 4, you couldn't leave it as 10 over 4. It would have to reduce to 5/2 anyway. And a lot of people don't want to have to reduce fractions, so they just do the division and write it as a decimal. But 5/2 doesn't reduce, so I just left it alone. So you guys have 2 answers. One of them was whole, one of them was not. Is that okay? Are we good before I turn the page? Don't everybody speak at once. I'm going to go ahead and assume that means yes. Okay, then on this page, we're going to do 2 of them up here, which if you guys look at those, notice how there's no 0. This does not say equals 0. So we got to move it. We got to move that 18. How do you move an 18? Subtract? Yep. We're going to subtract 18. Then that way that side is a 0. Tell me about the left side. Does anything on that left side combine? Like, are any of them like terms? Nope. You've got a squared term, an x term, and a constant. Okay, so if nothing combines, we just have to write all 3 terms side by side, but they have to go in the correct order. The x squared term always has to be first. The x term always has to be in the middle, and the constant always has to go at the end. If you set it up any other way, when you go to factor and put it in the asterisk, your numbers are going to be in the wrong spot. Why don't you guys go ahead and try that one? Since we already have this, why don't you go ahead and see, you've got the negative 18 up top, the 7 at the bottom. See if you can get your 2 sets of parentheses and your 2 answers. Okay, so it looks like, did you guys put 9 and -2? Do you have positive 9 and -2 in the asterisk? So it's one of each to get the negative up top, but then the bigger one always has to match the one at the bottom. So if there were more positives, you'd have a positive sum. Okay, so it would be x plus 9 times x minus 2. So then, some of you may have gone straight to your two answers. What are my two answers? Yep, x equals -9 and x equals positive 2. No, your parentheses are not your answers. Your parentheses have to be x plus 9 and x minus 2. But when you break them apart and you set them equal to 0, the x plus 9, you would subtract 9 to get your answer. And the x minus 2, you would add 2 to get your answer. So the two sets of parentheses are always going to be opposite of what your answers are.
And when you're doing asterisk, you always have to, doing asterisk, that means like you have to choose the greatest common factor.
Only if they have something in common. So like these three didn't have anything in common.
Because I used for the bottom asterisk, I got it wrong, because I used 3 and 7.
For this one?
Yeah.
You mean 3 and 6?
Yeah.
3 and 6 would make 18, but it wouldn't make the 7. So you have to look at the row of 18 and find the two numbers that would somehow make 7 also. All right, now letter B is not set equal to 0 either. So what would I have to do first? Subtract 6. Okay, will anything combine on the left side? Nope. So again, we just need to make sure that we get all three terms in the correct order. X squared first, x in the middle, constant at the end. Then before going straight to your asterisk, do those have anything in common? Aren't they all divisible by 2? Okay, so let's get rid of a 2. Let's do a GCF real quick. Just dividing every term by 2, because that 2 is really not needed for the asterisk. This will allow us to have much smaller numbers in the asterisk, okay? So if I divide the first term by 2, it's x squared. The middle term by 2 would be 2x, and then my constant by 2 would be -3. So the good news is this right here, what's in parentheses, that's all we use for the asterisk. And see, that's nice. When you can have a 1x squared in the asterisk, that's better than having a 2x squared. Because then you don't have to worry about like the reducing at the end and everything. So I always, if there's a GCF, I get rid of it. I bring that 2 out, and that 2 is not needed anymore. So we would have -3 at the top, +2 at the bottom, and then 1x's. So I mean, technically, once you guys do the asterisk, that'll give you your 2 sets of parentheses. Technically, this 2 that I pulled out is still there, but that 2 is not even going to be part of the answer. So I mean, like, do you really need that 2? No, I just wrote it there because that's technically how it should look. So what do you guys think about, well, there's only one way to make 3. 1 and 3. But 1 has to be positive and 1 has to be negative. Which one is it? The what? The 1 has to be negative and the 3 has to be the positive. Yep. So you've got x minus 1 and x plus 3 as your 2 sets of parentheses. You break them apart, set each one equal to 0, and then solve. Or if you felt comfortable and you just went to your 2 answers, that's fine. What I don't want to see you guys doing is writing your 2 answers. Like a lot of people will see this, x minus 1 in parentheses, and when they go to write their answer, they do this. They do that. And I'm like, no, that's not, we're solving for x. It's supposed to be x equals 1. So I always worry about the people who try to go straight to their 2 answers just because I'm afraid they're going to write it in parentheses rather than x equals. But just be careful. The x minus 1, I would add 1 to both sides and get x equals positive 1. And then the x plus 3, you would subtract 3 from both sides and get negative 3. Okay, how do we feel about those? We're about to do something slightly different on the next one. Okay, go ahead and take a look at the bottom. So now we have inequalities, okay? I don't know how much you guys actually remember from previous, it would have been like in, pre-algebra, I think is when I first do inequalities. But when you first learned about inequalities, we had and or problems back then. Well, you guys are about to have some and or some or problems right now. So, anytime you have this symbol, this one, it is going to be an or problem. So if it says y is less than or equal, or even if that was just a less than symbol, so less than or less than or equal, those are or problems. Okay. I'm always afraid I'm going to tell you guys wrong. This is only my second time teaching this, so I always like panic for a minute. Notice there's still a quadratic over here, so it's still just 3 terms. So we're still going to start this out the same way. Like we're still going to do an asterisk problem. Okay, so let's go ahead and get this set up. You've got a -3 and a -2. What do you guys think about my 2 factors? 1 and 3, and the 3 would have to be the negative. That would be correct. So here are my 2 sets. And I know it's not an equal sign, I know it's an inequality symbol, but we're solving it just like we would the equations. So if I had x plus 1 equals 0 and x minus 3 equals 0, we are just doing the same thing we were just doing. So I have x equals -1. And then this one over here, I'd add 3, so I'd get a positive 3 as my answer. Okay, so you started out the same way, but our answer, the way we write this, it says we have to write it in interval notation. Okay, so let me take you back to your pre-algebra, Algebra 1 days. Anytime you had an OR problem, this is what the number line would look like. You'd have -1 and 3. Because there was an equal sign, see this equal sign up here? You guys would have closed circles at each one. How did we shade OR problems? Where'd the shading go? Out. It went outward. They went opposite directions, right? That's what it would have looked like back in pre-algebra and Algebra 1. But we're big kids now. We get to write interval notation. So, what? Did I just say something about a pool? I said we're big kids now. We have to do interval notation. Not a pool. Okay. Anyway, we need to somehow show that all of our solutions are here or here without using a number line because we're big kids. So this is how you do it. Let me write it and then you guys will understand it, okay? Let me just write it first. Try to listen to me. Don't write it as I write it. This is what it would look like. All of my negative numbers that are all down here leading up to -1, they would be represented by -infinity. So all the negatives leading up to -1, okay? Now, because there was an equal sign, I have to make this closed bracket because it would be closed circle, okay? Then this part over here starts at 3 and then goes to all the positives, which would be positive infinity. So it would start at 3 and go to positive infinity. Now, there are different brackets. Anytime you're talking about infinity, you have to use normal parentheses because infinity is not a number, right? It's not a specific number. But these two are specific numbers and there was an equal sign, so I had to use that closed bracket. Now to show that it's this set and this set, you make this U in between them. It's called union. It's -infinity to -1 and 3 to positive infinity. That's how you write your answer. Ta-da! Here's the good news. You have way more and problems, and remember the and problems are just between. We will just have one set of parentheses for those. The only ones that are a little bit harder to write are the or problems, and you only end up having like one or problem. So write it on your paper. Write the answer down.
Right there would be your final.
Yep, this right here. Because it says it has to be written in interval notation. Like if you were back in Algebra 1, I'd make you do... Huh? Well, that's what I'm saying. If you were back in Algebra 1, we would do the number line. But we're grown. We have moved on to Algebra 2. So we are learning interval notation. Huh? Sure is. Actually, this is what you would see in like pre-calculus, calculus, and in like the Math 136. Yep. And it's a requirement for Algebra 2 now. All right, cool. Here's the good news though. I mean, all this stuff you guys should be okay with, the blue stuff. That's what we were just doing up there. That's no different. The only difference is how you write your final answer. Okay? All right, turn the page. We're going to do some and problems. We've got greater and then greater than or equal. So anytime you have greater or greater than or equal to, those are the and problems. And you guys are going to like how we write our final answer for that. It's way easier. But you guys are all plenty capable. You guys are all smart. You can learn how to write that interval notation one time. Okay, so we've got positive 8 and negative 6. What are my two factors? Is it 1, 8 or 2, 4? 2, 4. Both positive, both negative, or one of each? Both negative. The top is positive, so these two have to match. If this had been positive 6, they'd both be positives, but since it's negative 6, they're both negatives. This is why the factoring in Algebra 1B is so crucial to this class, because you have to do factoring over and over and over again. And I would say the majority of the time we do asterisk problems way more than any other kind. Okay. X minus 2 equals 0, x minus 4 equals 0. So wouldn't I just add on both of them and get two positive answers? Yep. I'd get x equals positive 2 and x equals positive 4. So if we were back in pre-algebra, algebra 1, we would have a number line and we'd have circles at 2 and 4. Notice how this symbol does not have an equal sign. So we would have left them open. But because it was an and problem, where did the shading go? In between them. So are you ready for interval notation? Super simple. There's no equal sign, so we use normal parentheses. One set of parentheses. Which one's the smaller number? 2, 4. Done. So easy. Because this says that all of our solutions are between 2 and 4. That's what that means.
So basically,
This is not to be confused with an ordered pair. Okay?
you already say that, like you write it like an ordered pair.
You write this one like an ordered pair because there's no equal sign. If that had been an equal sign, they'd be the square brackets. They'd be these. Look, they'd be those. But there's no equal sign, so we use just normal parentheses. But yeah, the and problems, it's a smaller interval because you're just using what's in between the two numbers. You're not looking at all of these going all the way to negative infinity and all of these going to positive infinity. You're looking at just this small section. So this right here is the final answer. 2 to 4. Okay, then the bottom one. It is greater than again. Well, it's greater than or equal, so just real quick, I'm going to make this note. Because there's that equal sign, we'll use those square brackets. Okay, and greater than is an and problem. positive 3, negative 4. At least they're being nice. They're giving you, if you have a 3, there's only one way to make 3. It's 1 and 3. 2 positives, 2 negatives, or 1 of each. Both. Did you say both negative? Both negative. So x minus 1 times x minus 3. All I'm doing is breaking them apart right now, which I'm assuming some of you have already skipped that and put your 2 answers. And that's fine, but that's why I got quiet. I'm just finishing this up. Okay, so it looks like our 2 end points are 1 and 3. So, because there was an equal sign, you make your closed brackets. Which number is the smaller one? So 1, 3. Huh? No, this is an and problem. And problems are easy. Or problems are harder to write the interval notation. And that's just because this is the first time you guys are seeing interval notation. If you had seen it before, it wouldn't be that big of a deal. But again, if this were, if this had been a number line, we would have had 1, 3, we would have had closed circles because of the equal sign, and then we would have just shaded in between. So essentially, it's just the fancier way of writing what this looks like. Then we only have one more problem to do on the next page. So you just flip it to the back, flip it over. Less than. The best one, right? This is or. And then there is an equal sign, so we'll have this, you'll have like negative infinity to something, and then something to positive infinity. I'm just showing you those symbols. I mean, we'll do it at the end, but anytime I start a problem, of course, I'm a math teacher, so I think about math. I think about things before I do them. I'm not sure a lot of you are there yet, but I like to always kind of think ahead. Like, I know this is or, I know what my symbols are going to be at the end. I just like to be prepared. And then they gave you 3 again. I promise you, it's not always going to be 3. For some reason, they just kept using 3 and 4. Anyway, what are my 2 factors? Positive 1 and positive 3 this time. They're both positives. So we have x plus 1 times x plus 3. And then if you break them apart, or, some of you go straight to your 2 answers, I would end up subtracting on both of them, so both of my answers will end up being negatives. Ooh, almost put the wrong number there. So, back in your previous math days, this is what the picture would have looked like. Negative 3 to negative infinity would have all been shaded. Negative 1 to positive infinity would have all been shaded. So you've got 2 sections. We've got 2 sets of answers here. So, automatically put a parenthesis because negative infinity is not a number. It's not one specific number, so it has to be the parentheses, okay? Which one is the smaller of the 2? Negative 3. Remember, negatives are different. Okay, now this was an equal sign, so you've got to have, the negative 3 needs to be with a square bracket around it, okay? Then the U for union, meaning both sets are answers. Square bracket, starting at the -1, going to positive infinity with parenthesis. That is your second OR problem. And that's also the end of your note.